Hello! In this video we'll talk about compressed instructions. So far we've looked at the 32-bit version of the RISC-V architecture, but RISC-V is trying to compete against microcontrollers, and many 16-bit microcontrollers pack their instructions in only 16 bits and therefore need about half as much code storage. And since code storage is often the biggest part of the cost of a microcontroller, 16-bit processors can have an advantage. So RISC-V and other instruction sets such as ARM have defined 16-bit compressed instruction versions. This is an optional feature in RISC-V, but most RISC-V compilers will generate a mix of 32 and 16-bit instructions whenever possible to save code space. The idea is to replace the common integer and floating point instructions with 16-bit versions. These compressed instructions have a mnemonic that starts with C. So for instance, instead of add, we have a compressed add. Instead of load, there's a compressed load and compressed add immediate. So here's an example of a program that uses compressed 16-bit instructions. So we have I equals 0. So there's a compressed load immediate. Let's keep I in S1, and we'll load in 0. Next we need T2 is 200 for comparison. So we need to put 200 into T2. But 200 is too big of an immediate to store in a compressed instruction. So we used a regular add immediate. T2 gets 0 plus 200 to handle the large immediate. Now we want to see if we're done. We continue if I is less than 200, so we want to leave if I is greater than or equal to 200. We use a branch greater than or equal to S1, T2, and done. And again, this takes too many bits to do the branch to pack into a compressed instruction, so this is an uncompressed version. In our program, we wanted to fetch scores I and add 10 and put it back. So we could load relative to some T0, put it in T1, add the 10, and store it back. Looks like we didn't initialize T0, should have been pointed to the beginning of the array. Then we could add 4 to S0 to go to the next part of the base address. So this looks like this should have been S0, base address. So bump the pointer up to the next part and add 1 to I and continue until we're done. So that was an example of a program where many of the instructions were compressed. So to make instructions fit in only 16 bits instead of 32, some compressed instructions are restricted to only using a 3-bit register identifier instead of 5 bits, and those select one of the 8 registers between X8 and X15. Also, the immediates are fairly irregular. They're generally in the range of 6 to 11 bits, depending on how much we can pack in, and the opcode is only 2 bits. So here are a bunch of different flavors of compressed instructions. R-type instructions take one register that's both the source and the destination. Second source, they do the operation specified in funct4. I-type instructions use one register as both the first source and the destination, and they have an immediate packed in these 5 bits plus these 2 more, giving them 7-bit immediate, and a funct3 to tell you which type of immediate instruction. Same way for stores, branches, jumps, and so forth. Jumps can take an immediate that is looks like 12 bits, no, 11 bits long.